A previous model of this device that utilized the only components available at the time. This new model is much simpler and more effective. Just like the old version, the static electricity from this device attracts sand and other fine particles to my hand, creating a dust storm as they jump to collect a charge, then fall again to release it. The heart of this device is a negative ion generator made to operate on DC power. On one side will be a thin red and black wire as the input for a battery, and on the other will be a well-insulated red or white wire which is the high voltage output. This model has a second black wire on the output side which acts as a ground. For generators that don't have this dedicated ground wire, I'll be showing where one can be added later. With the power input side determined, the thin black and red input wires can be trimmed down to a more manageable length. Not too short, or a mistake or repair would leave too little wire to correct the problem. A 9-volt battery harness will be connected to these wires, but a number of things will need to happen first. A section of heat shrink tubing is slid over the red wire on the generator in preparation to cover the connection it will make to one of the terminals on this on-off switch. The wire is twisted onto the terminal and soldered into place. With another section of heat shrink tubing over the red wire on the battery harness, it can be soldered onto the second terminal of the on-off switch. The insulating tubing is slid over both terminals, and I can now move on to the black wires. The two ends are connected with a simple twist and soldered to complete the circuit. If the generator being used lacks a dedicated ground wire, a replacement can be soldered onto this splice before it's covered by more tubing. My work on this part of the project is done, so I can now use a lighter to permanently shrink the insulation over the connections. As they are, these electronics need a housing to contain them. For this I'll be using a plastic travel case for a bar of soap. This case only needs a few simple modifications. The first is a notch cut out of one side for the switch. This is easily done with a hot penknife heated by a lighter. On the opposite side of the case, 2 holes are made for the output and ground wires. The case is now completed and ready to accept the electronics. The 2 wires are fed in first until the generator rests comfortably in the center of the housing. The switch can then be lined up with the notch cut for it and glued in place, being careful not to get glue on the switch in such a way that it would prevent it from turning on and off. A 9-volt battery, when snapped into the harness, should now have room to sit right against the generator and allow the case to close. Once done, a flip of the switch will cause arcs of electricity to jump between the output and ground wires, indicating that the device is working properly. To allow a buildup of static electricity in the user, the black ground wire will need to be in contact with the surface that the user is standing on, and the red output wire in contact against the user's skin. To accomplish this, an extra 3 feet or so of wire is spliced on to each wire coming from the case. On the end of each wire that has been extended, I'll be using a piece of aluminum from a soda can to increase the area of contact. Both sides of the aluminum need to be sanded lightly to remove any paint or enamel before use. The end of the red output wire can simply be taped to a section of the aluminum as shown. The black ground wire requires a little more work because it will need to be held to the bottom of the user's shoe. For this I use a Velcro cable strap. A small hole is made in the strap and the ground wire is fed through it. About in the center, the section of aluminum is folded over the wire and taped in place to maintain a solid connection. To use this device, I simply place the box in my pocket and run the 2 wires down to one of my shoes. The end of the output wire is placed inside of my sock, so it presses tightly against my foot. The static charge will be generated through this connection. The Velcro strap on the ground wire is then wrapped around the shoe, so that it is isolated from the wearer through the rubber sole, and the aluminum strip makes contact with the surface being walked on. The more conductive the surface is, the better the device will work.